can see, this is the last slide. But then it has a lot of pointers that come handy when you are working with actual data. If you want you to take screenshots or write it somewhere, you can use it as a guideline sort of thing when cleaning your data. It's not a complete list, but then these are very important things that you can't run off from. These are like the basic stuff. There are more things like clustering and all, but then for now, these are the parts that we'll quickly do. Yeah, I will send the slides later. Thanks for the question. I forgot to say that. Yeah, I'll upload the slides, upload the code file, and it will be all online. You can refer it any moment. And I'll try putting extra content that I spoke that are not included in the slides. I'll put everything in there as much as possible. But then I still would recommend you to write notes, because many examples that I say, I have not written it, and I speak it like, if I get a new example, I just speak it. I have not written it somewhere. So if you have something extra, if you get something extra, you can always write, and it helps you remember. So yeah. So just for the timing, we'll just go back. Uh, we'll go through that again. We saw the difference, we saw how to define a problem, we saw requirements, we saw how to design it, we saw where to share that, where do we search for the data. Either they provide you, the stakeholders provide you, or you get it yourself from over the internet. That depends on the problem. Then coming to the second part, we'll just be covering the data cleaning today. We don't know if we'll be able to cover it in 40 minutes or not. We'll try to do it. If anything's left, we'll start a new meeting. And yeah, so we'll go for the data cleaning again, this part. So there are three major parts of data cleaning that I would like to cover. The remove unwanted fields, handle null values, handle categorical values. So what's handle unwanted fields? Again, so field is basically an analogy for your database columns. I mean, in a simple sense, you can consider it as a database columns, but then they can be like uh, multi-valued fields. So I'm using the word fields here to not make something wrong. So yeah, you for now consider it as your database ka column, and when I say the row or a tuple, that's basically your database ka table ka row. That's your database table row. Yeah, that's also in a machine learning language. That's a single training example, and your columns are your data points. So what do I mean by remove unwanted fields? So when you get the data, it's often directly from a transaction processing system. That's basically your customer relationship management system, or your billing system, or your sales system. It might be from some different place, and the people, the database administrator or the data engineer might have cleared the unwanted fields. By unwanted fields, I mean including personal information, and there might be other fields. So the first thing is, you have to remove personal information that's not useful to you. Like in a typical problem, the names of the people won't be useful to you, because they won't be affecting your final prediction. That's not the right thing usually in most of the cases. They might show you like other features like genders and all, but then right now we'll consider personal information as a superset of names and IDs and everything. IDs can be your database primary keys, foreign keys. Again, that won't directly affect your predictions, affect your final analytic output, so you might want to remove that. But then at the runtime, if you are not using that ID, in most cases you'll have to generate your own ID, or you will use the ID that's generated by the framework that you are using. ID is necessary, but not necessarily the ID that you're getting from the unclean data. Then you'll deal with null values. Null values is all when you create a database in your second year, when you start creating database, you put this word not null. You say that primary key cannot have null values. So these values have to be dealt very properly. I mean, those are like one of the most important things. Again, your machine learning model cannot deal with null values. So you have to, there are various ways to do it. if you have a column which has a lot of null values as a column, the column for a lot of training examples you have null values, you better remove the column because it's not providing a lot of information. If you can always fill it, but then for now it's an option. Drop the rows is basically dropping the training examples. So for example, a specific training example was being written, like given to you by a bad system, or I would say not very well maintained system. So that specific training example or a group of training examples that have a lot of null values, they have a lot of incorrect values. So if you have other data points, or if it's affecting you in a bad way, you can just get rid of it. So again, this is analytics, it's not your transaction processing system. Every training example would provide you value, but then it's not necessary that you keep all the training examples. Second thing, incorrect values, they give you they make an issue. But then when you have lots and lots of data, we are living like terabytes of data, a single row won't affect you a lot. But you should always get rid of incorrect values too, but then they won't affect as much as it would affect your transaction processing system. A transaction processing system are your basic banking system, sales system. A wrong debit credit in your account would create a lot of issue. It will like poison your entire account passbook. But then a simple wrong value won't affect, like you have millions of training examples for predicting stock. A single training example won't affect as much to the final prediction. Yeah, coming back to null values, I went off track, really sorry for that. So again, coming back to null values, yeah, null values must be removed. You can drop the entire row, you can drop the column. Third option is to impute values. What is value? How do you impute values? So you might have a row, you might have a column which has very less null values, and you think that this column is very important for your predictions. So what you want to do is you'll fill those null values by some values that you are creating. You can use some statistical values like mean, median, mode, or you can go ahead with using the most common values. Because you think that the values, the training example that has these values, by training example again I mean the row that has this exam, that has this null value, is important for you, so you don't want to drop the entire row. And also the column, the other training examples have the value. There are very little training examples, again rows, that don't have this value, so you will fill those values. So imputing values means filling the values. They can be statistical values like mean, median, mode. They could be off the shelf values, like you might see that most of the people are prefer a apple. Example, just an example is preference form. Most of the people prefer an apple. There are two people who have not written their preference for the fruit field, so you just put apple there. I mean, it poisons it, but then yeah, that's an option. And then another point is to handle categorical values. So when you get the data, it's always not numbers, but you can deal only with numbers in analytics. So you have to convert each of the input into a numerical value. It's necessary for you. So basically use data dictionaries. Again, for all of these examples we'll see code examples. For all of these topics we'll see code examples. Yeah, so let's begin with the code example. So for the sake of making it easy and to create it more reproducible, and it should to help you better to like recreate the code that I write, you don't have to create any environments on your system. You can directly create notebooks. I'll show you how to do that, and you can do everything from your web browser. So that would help to get away, like go away from the problem of installations, of creating environments and everything for a while for the course. Later on you may want to do that, and I can create small videos for that or direct you how to do that. So yeah, so the data that we are using is a very well-known data for beginners. It's basically predicting predicting if a person in the Titanic ship was drowned, you want to know if the person would make through it. So everyone has read about Titanic somewhere or the other. Many of you have might went through like watched the movie and all. So we all know that people die when ships drown, and you want to predict like who is the, like what kind of people would not drown. For example, they would get saved, they might get help or something. So this problem, the definition is to predict if the person would get saved from a disaster. You have lots of data from previous information, from previous drownings, and you have to predict each time a person boards. So I'm going through the first part, the problem definition part. The requirements go in line. So let's see what data do we have. Yeah. So the first row, so this is a basically this is a data dictionary. So you get the names of the variables, the names of your row columns in a typical database language, and the definition is what do they mean, and the keys tells you what do you like, how do you infer the values. For example, for the embarked, you have three values: Cherbourg, Queenstown, and Southampton. So that's basically the kind of values that you may see. So I'll go through the topic. So the first column is your survival. The survival is basically if a person will survive. This is the target column. You'll hear these terms a lot of time: target row, target column, ground truth. These all mean the same. What is the final output? Like that's what you want to predict: the target value or the ground truth. Uh, so it's the survival statistic. It can be 0 to say that the person did not survive, or 1 that means the person survived. P class is basically the class of the ticket. So in normal sense, if it's very similar to what we have in the trains and buses, you have first class, you have second class, you have third class. So they provide you that. Then your sex is basically again the gender. I need not say that it's gender, male, female. Then age is again self-explanatory. Siblings is basically they tell you if a person has their siblings on board. So how does it affect? So a person, a man who has a family, or a woman who has a family, would tend to save them with himself, which puts him also in the danger, like more danger. So this is how this would affect the person on board. It would change the survival statistics. Then your ticket number, your fare, your cabin number, embark, these are all different columns that we have. Like all data sets, whenever you access, either you should have the data dictionary with you, which means what a specific column means, or you will ask a lot of questions. You should ask a questions, and it's very, very important that you understand the data yourself. That helps you build the intuitions which to decide which are the columns that you would want to use in the final system. So you should always understand the problem and the data very nicely. Those are like the stepping stones. So yeah, so this is the data dictionary, and again they say here that they have given you a train.csv and a test.csv. So if you come here, the train.csv file is loading. Okay, so it will have all the columns that they say in the data dictionary of passenger ID, survivor ID, P class, whatever. And your test.csv will include all the rows, all the columns that train.csv have, but it won't have the target column. That's the survival statistic. That's something that you want to predict. It won't have that. So in a typical project, which is not a Kaggle project or a competition, the business guys will give you a lot of data. So you'll create your own train things and test things. We'll see this. It's more machine learning specific, so we'll see that in the building models part. But then just to give an idea, this is how a Kaggle competition usually is. You have your train.csv or training data, then you have your test.csv. That's basically what the values that you want to predict. You won't have the output for the test.csv, and the train.csv and test.csv needs to be mutually exclusive. You can't have the same training examples in both of them. Training examples are the rows, just a postscript. Yeah, you don't want to have them, you want to have them mutually exclusive. If they are overlapping, you will get better accuracy in most cases, which actually poisons your model. You won't be able to analyze if your model is working properly. So going ahead with it, so in a typical Kaggle problem, or so one more thing, Kaggle allows you to upload your own data. So what usually you do is your machine won't be fast enough to do your analysis or create machine learning models. So you create a new data set on Kaggle, you upload your data, and then you create notebooks out of it, and then you can work with it. So what you can do is you can click on the notebook, and you can click on this button, new notebook, which will create a new notebook. Let's show it right now. So it will ask you the type of notebook, the language, and then you click on create, and it takes a bit of time, like it takes a minute or two. So I have already created a notebook for you. Yeah. So what's a Python notebook? So for first thing, for beginners, what is Python? Python is a language that if there's someone who's living under a rock and who doesn't know about Python, I'll just clear it off. Python is a language that allows quick prototyping. It has its own set of features which are different from any other language. It's an interpreter based language, so you don't need to compile your language. You just write it and it runs it. It checks all the things like all the errors and all during runtime. So it's more uh, it's easier to write Python in most of the cases, like easier to write, but then you will get a if you are not writing it properly, you'll get more bugs. And then you don't need to define types of variables that you include. In Java, you usually write end. In Python, you don't need to write that. That was about Python, a basic example. It's a great language. It's very much preferred by data scientists and people who work on automation and all. Yeah. So then, yeah, it is a language. So you should be able to write code and then run it through your command line or use Visual Studio. What is this nice looking interface? This is a Jupyter notebook. Yeah, it creates your coding part of your data science very easy. So what uh, is this? So it allows you to write codes of block, and you run it. You get to see the output, but your runtime has not ended. By runtime, I mean usually when you write a piece of code, you run a piece of code. Your system takes the lines of code that you have written, it executes it, it gives you the output, and it exits. But then in this case, it doesn't exit. It stays there and it waits for you to give it more. So it saves all the variables that you have written. It has all the code, and then it just stays there, and you can put in more lines to it. Okay, so we have 10 minutes. I guess I'll quickly wind up for a while, and then we'll have to start a new meeting. We have just 10 minutes more. Cool. Yeah, so this was about the Jupyter notebook. What else? You can write different codes here. So I'll write something here. I'll write something here. And then what I can do is I can keep running them in any order that I want. I ran this part. Then I can run this again. So it makes it very feasible to do your prototyping. So one quick example why it helps you is basically when you create a script for training a model. So in the top you will have if you will have code to like uh, process the data, that might take a long time in itself, maybe an hour or something if it's tabular data, if it's a small data. And then you'll have 2-3 hours for training your model, and then in the final part you'll test it, will save the model. Oh, and Python is a interpreter based language. As I said, it's not a compiled language, so you won't see the errors in the initial state. You will see only basic linting errors. Linting errors basically uh, your textual data, you've not put tabs properly and all. The main variable errors also are pulled till the runtime, you won't get them. So your data was processed properly, your model was trained properly, but while you were saving the model is basically creating a file of the model so that you can use it again in the next time. Your code failed. So now all your 5 to 6 hours of computations that you waited very nicely for it's failed because your script failed. So how this helps is you can write the code and you can test it, and if your part where the model is saved fails, and if you are lucky to put that in a separate block, you just have to run it again. You have to solve the error and run it again. You don't have to run the entire pipeline. So we have 8 minutes for the meeting to end. So what I'll do is I will wait for 2-3 minutes to take questions. If you have any questions, you can ask why Python, or you can ask why Jupyter Notebook, why Kaggle. I'm ready to answer them. You can put it in the chats. You can ask anything you want. No need to worry at all. So I'll wait for 2-3 minutes. Then if there are any questions, we'll wait more. And then we'll stop the meeting and we'll share another link. Really sorry for these meetings, but then we don't have a pro pack of Zoom, so we need to do this 40 minutes ka menial work. Really sorry about that, and thanks Keith for helping in this part and many other places. Yeah, any questions? Please write it down in the chat box. Okay, so we have why Python over R. Great, I expected this. Uh, why Python over R? First of all, there's nothing which says that Python is better than R. It's just that Python is easier to learn over R, and it has a huge community again. And one thing that makes me use Python over R is basically it's a general purpose language. Python is a general purpose language. R is a statistician's language. It's more geared towards helping the statistician or the non-tech people, not exactly non-tech people, but analysts and all to do their analytics properly quickly. It's very simple. It's much more easier to create a web API in Python and deploy your models as compared to R. Just again, I'm not saying Python is better, R is bad. It's just that I started learning with Python and I'm preferring it because you could like deploy models and you have lots of libraries. And again, it's simple to learn. R is a bit difficult to learn, but then you get really beautiful plots in R. Like the visualizations that you can create with R, the visualizations you can easily create very good looking visualizations in R. It has an upper hand in that case. And although those math commands are really good in R, but then yeah, for the sake of simplicity and all, we are using Python right now. We are free to use R if you want. We know R not as good as Python, but we know it. We can help you with that too if you want to do R. Okay. Anything else?